let's continue on hormonal regulation of spermatogenesis. So focus on the right hand side of the slide over here. I think that this diagram is easy enough. Okay. Hormonal control of spermatogenesis start at hypothalamus. Hypothalamus will release the GnRH, gonadotropin releasing hormone, at the onset of puberty. Okay, once the GnRH presents, okay, it will stimulate the anterior pituitary. Once anterior pituitary is stimulated, release the gonadotropins. Gonadotropins are the names for FSH and LH. Okay, LH and FSH called gonadotropins. Okay, FSH secreted. It will travel to the sex organ. In the male, the target cells is Sertoli cells. Okay, FSH bind to Sertoli cells. LH targeted cells is Leydig cells. So LH bind to Leydig cells. What happened after that? Leydig cells will stimulated and then produce testosterone. Okay, Sertoli cell once bind by the FSH, it will stimulated to start the spermatogenesis. To start spermatogenesis, testosterone is necessary. Okay, once testosterone secreted by Leydig cell, it will diffuse into the seminiferous tubule. So present in the seminiferous tubule fluid, it will initiate the spermatogenesis. Okay. Spermatogenesis start to produce sperms. At the same time, Sertoli cell produce inhibin. Okay, inhibin act as negative feedback to the anterior pituitary to slow down or to stop produce the FSH. Okay, inhibin give effect to anterior pituitary to slow down the FSH. The testosterone secreted by Leydig cell. Okay, once testosterone is high and spermatogenesis also start to produce sperm. So testosterone act as negative feedback for hypothalamus and anterior pituitary. Okay, hypothalamus will stop or slow down produce GnRH. So eventually slow down the anterior pituitary to form LH and FSH together. So that's how spermatogenesis being regulated. Okay. The wording over here. Sertoli cells also produce ABP, androgen binding protein, okay, secreted by Sertoli cells into the lumen of seminiferous tubule. In response to LH, the Leydig cell makes the testosterone. Testosterone get into the circulation and lymph vessel, okay, and then taken up by the Sertoli cell. It eventually enter the seminiferous tubule lumen. In seminiferous tubule lumen, testosterone will bound to ABP. So bound to ABP. So this binding makes the testosterone higher concentration in the seminiferous tubule fluid lumen. Okay. So once testosterone present, it will start the production of spermatocytes. Okay, within the lumen, ABP function to transport testosterone to epididymis. Testosterone can enter the seminiferous tubule by at least two ways here. Once it can across the blood testis barrier. Another one, it will get into the circulation, lymph, and this one will travel to the body system. So it will stimulate the response or the reaction is it will stimulate the secondary sex characteristic, the build up muscle. Yeah. Okay, again the same thing. Sertoli cell release substances to tubular fluid, contact with the germ cell, then initiate the spermatogenesis, produce ABP. ABP bind to testosterone, convey to germ cell to start the spermatogenesis. Sertoli cell also produce inhibin, so it acts as negative feedback to anterior pituitary to stop FSH. Okay. Alright. Your slide have more longer sentences of explanation about hormonal regulation or spermatogenesis. Okay, you can use that for your essay writing. Okay, I think that's all for hormonal regulation of spermatogenesis. Simple. Continue from hormonal regulation, we look into sperm abnormalities. Okay, sperm abnormalities, they are like stages. Primary abnormalities arise in testes, meaning the spermatogonia, any problem relate in the formation of sperm in the testes, or the testis itself has abnormal structure or that affect the first stage of spermatogenesis in testes. Secondary abnormalities arise in epididymis or ejaculation. So the secondary abnormalities, meaning the spermatogenesis already occur, already form the sperms. Okay, already undergo spermation. But maybe the abnormalities is maybe the packaging of the glycoprotein in the when they are being washed in red testes, aphasia, vasa aphasia, and to epidermis storage when they are default there. So that is secondary abnormalities. The primary abnormalities, the sperm cannot start the spermatogenesis itself, or the sperm already start mitotic division, but it cannot complete until produce the spermatids or spermatozoa. So that is primary abnormalities. Okay, there are another way to look at sperm abnormalities is the major and minor problem. So major problems can cause early embryonic death or prevent fertilization. So this one can relate with the chromosome number. Okay, the chromosome homologue did not separate completely, or produce the sperm with absence of genetic material. So all of these is the major problems which cause the early embryonic death, or fertilization cannot happen at all, or maybe fertilization happen but the stage after that is destroyed or stopped. Okay, acrosomal problem there, example, an acrosome problem. So it will prevent the zona entry. Okay, prevent the fertilization. So when the fertilization cannot happen, that consider major, or the major problem, but secondary abnormalities. The sperm is produced but it cannot penetrate the egg. Minor problems such as the tails abnormalities, two tail instead of one. Okay, it will cause some problem in sperm movement. Okay, so these consider minor problems. So this minor problem can be helped by undergo the ART, artificial reproductive technology. Okay, next. Okay, sperm abnormalities can be viewed in 3. I think this slide is much better. Okay, whether in terms of sperm count, okay, the number of the sperm should be normal sperm count is higher, but when it is less than certain ratio, there are guidelines of the sperm number count, the sperm count number. Okay, so this man will face fertility problem. Okay, another sperm abnormalities, we look into the sperm morphology. The sperm should be having like a round shape of or oval shape head, and then mid piece, the neck, and one tail, one flagellatum. The morphology abnormalities can be the shape of the sperm. Instead of oval shape, or the round shape become knob shape, or maybe there are two head, or two head, two head of the sperm, or the tail itself, from instead of one they have two tails. So that is sperm morphology. Another sperm abnormalities is the sperm motility. They have all the shape, morphology, round shape head, mid piece, and one tail, but the tail is lack in terms of movement, the motility. This can cause fertility problem also. Okay, so from picture over here, can you identify any abnormalities? So let's see. Okay, here the tail is too short. Okay, let's see in terms of the head. Okay, so maybe you can see here, this also abnormal. Okay, this can be abnormal. This totally abnormal. This one, the head shape. Can you identify any sperm that have two tail? Two tail. Alright, that's alright. Okay, so the normal sperm should have smooth oval shape head. Okay, the length and the width is like that, 5 to 6 micrometers, 2.5 to 3.5 micrometers. Okay, well defined capped, okay, acrosome. No visible abnormalities of neck or mid-piece or tail. Okay, no fluid droplets in the sperm head that are bigger than 1/2 of the sperm head. Example, these can be abnormalities. Okay, alright. Okay, yeah, maybe this one. Okay, the A is knobbed acrosome. Okay, B, knobbed acrosome beaded form. Okay, C, pyriform head. D, pyriform head. Severe, C is severe, D is moderate, and E is slight. So the shape of the head is actually need to be really smooth oval shaped, like this one here. So might be in this picture a lot of it is the sperm having head abnormalities. Okay, we have to identify the knot versus smooth oval shaped. Alright, so there are causes over there. Knob acrosome, common form, abnormal parthenogenesis due to disturbance in the testis heat regulation. B, the knobbed beaded form, knobbed acrosome beaded form. Okay, systemic illnesses, toxicity, nutritional deficiency can cause fat deposition around scrotum. This one can influence the sperm formed with knobbed acrosome. Pyriform head here can caused by abnormal spermatogenesis due to disturbance of either heat regulation in testes or endocrine control. Alright, yeah, this is some of the more of the sperm abnormalities. I think you can read it by yourself. Okay, this slide here, two-headed sperm cells, so like that. Tapered sperm head, not oval shape, right? Okay, round cells there. Large midpiece, yeah. Broken tail. Vacuoles in head. Right? Alright. Okay, we stop here for spermatogenesis.